Hi guys, we're going to continue working with solving polynomials by factoring. So we're going to be looking at solving polynomial equations, that is, by factoring. And now we're going to look at factoring by grouping. That would be where we take terms of a polynomial equation and group them together to try to find GCFs, or greatest common factors, within those groups of terms. So for example, in this 4-term polynomial, I'm going to group the first two terms together, x to the 6th plus 4x to the 4th, and these two terms together, negative 16x squared with negative 64. I know that there is a GCF for these two terms, and there's another GCF for these two terms. The GCF for the first two terms is x to the 4th. I can divide x to the 4th from each of these. And the GCF for these two terms in the second set of terms is negative 16. I can divide negative 16 from each of these two terms. So if I do this, that means that when I divide x to the 4th from x to the 6th plus 4x to the 4th, if I divide out x to the 4th, what I'm going to be left with is x to the 6th divided by x to the 4th gives me x squared. And of course, 4x to the 4th divided by x to the 4th is going to give me 4. So now I have that GCF actually factored out of those two terms. Over here, when I divide out the negative 16, when I divide negative 16x squared by negative 16, I'm going to get x squared. And when I divide negative 64 by negative 16, I'm going to get a positive 4. So when I've factored out the negative 16, I'm left with x squared plus 4. In fact, I have x squared plus 4 as the binomial that is left in both of these sets when I have factored out the GCF. So I now recognize that x squared plus 4 is another common factor for this expression and then this expression within the equation. So I'm going to factor x squared plus 4 away from the terms that are x to the 4th and negative 16. This is what I mean by factoring them away. I'm going to divide those away, which means I'm dividing, or I'm writing it out over here. X squared plus 4 is going to get divided away from x to the 4th minus 16, so that the other factor here, the other factor is x to the 4th minus 16. So now I've done one more layer of factoring, and of course the whole equation is still equal to 0. What I'd like to point out is that when I look again, I can see clearly that this binomial can be factored some more. This is a difference of squares. So because x to the 4th and 16 are squares, this is a difference of squares, so it can be factored again. The factors for that, I'm going to remind you that we still have x squared plus 4 as a factor here, but the factors of this particular binomial are going to be x squared plus 4 and then x squared minus 4. So I have factored this one more round, and these are the two factors that I get as a result. The whole polynomial is still set equal to 0. I'm going to look one more time, and I notice that x squared minus 4 is also a difference of squares. This can be factored one more time. So I'm going to factor that one more time so that I have now x squared plus 4, x squared plus 4 again. That's from here. And then I'm going to factor this guy out so that I've got x plus 2 times x minus 2. So the final set of factors for this polynomial equation are x squared plus 4 times another x squared plus 4 times x plus 2 times x minus 2. And again, the whole equation is set equal to 0. So now that I have it completely factored, I'm ready to solve. I'm going to take those factors and set them equal to 0. You'll notice that I have the first two factors highlighted in red, and that's because they are the exact same thing. I only need to set this factor equal to 0 once if it's the exact same factor. They are both still part of the polynomial. However, because it's the same factor, I only need to solve it once. So that's the first equation I can write based on these two same factors. Next, I'm going to write x plus 2 equals 0, and then x minus 2 equals 0. So I have three separate equations based on the factors of this polynomial. Now I actually need to solve them. So I've got x squared is equal to negative 4 when I subtract 4. I've got x is equal to negative 2. That's here when I subtract 2. And then here I've got x equals 2. That's when I add 2 to both sides. These two parts, or these two equations, are already solved completely. Over here I need to take a square root of both sides so that I can get x. Remember, when you take a square root, you're going to have a positive and negative factor. And also keep in mind that if I were to take a square root of negative 4, I'm going to get an imaginary number, so I get 2i. So all of my solutions for this particular example are x equals plus and minus 2i, x equals negative 2, and then of course x equals 2. This means I have 4 solutions, 2 real solutions and 2 imaginary.